You're watching NASA TV.
Good afternoon and welcome to NASA's Johnson Space Center. I'm Anna Schneider with NASA Communications, and today we're here to discuss 3 upcoming spacewalks outside the International Space Station scheduled for June 13th, June 24th, and July 2nd in support of space station maintenance and upgrades. Our briefers today are Dina Contella, Deputy Program Manager for the International Space Station Program, Sandy Fletcher, EVA 90 Spacewalk Officer, Nicole McElroy, EVA 91 Flight Director, and Faruq Sabur, EVA 91 and 92 Spacewalk Officer. We will start with some initial remarks from each of our briefers before opening it up for questions. As a reminder, for those on the phone bridge, you can press *1 to join the question queue, and for those following us on social media, you can use the hashtag #AskNASA. And with that, I will go ahead and turn it over to Dina for opening remarks.
All right, thank you. And thanks, everyone, for joining us and tuning in today. Before I get into the spacewalks, I would like to just give you a brief rundown of how operations are going on the International Space Station. Of course, we had a successful Starliner docking on Thursday, and we welcomed Butch and Sunny on board, as you heard from the post-docking media press conference. But I wanted to add that they also brought with them an extra pump for a urine processor of ours, and we immediately pulled that out, and on Friday had the ISS crew install that, and now the urine processor is working again. So great news on that front. And of course they brought Butch and Sunny, and Butch and Sunny are there are an extra set of hands, not to make it so utilitarian, but anyway, but it's really great to have them on board. Of course, they've been doing the objectives associated with their mission, the crew flight test mission, and trying out habitability and testing things inside that spacecraft. But we've also already put them to work on ISS doing some science objectives, which is great because, of course, we have the 3 spacewalks upcoming, and we have a lot of EVA preparations that are necessary. So the ISS crew has been very busy with that. So having Butch and Sunny available to perform some key critical science has been outstanding. So it's really great to have everyone on board. You know, in terms of the Starliner vehicle, it's doing great on orbit as well. You heard after the post-docking press conference that there were some, observations during the ascent and rendezvous that we'll be working through while it's sitting on ISS and docked to ISS. And so we do have commercial crew program, Boeing, ISS teams all integrated, working very well together in order to come up with a forward plan for getting us in the best posture for that undock and reentry. So I'm just going to give you some examples from an ISS perspective, but you heard about the sublimator. Sublimator used more water than was anticipated. So from an ISS standpoint, we've been looking at the best water that we can give them to help them top off the tank and what kind of adapter is necessary in order to get the water into their tanks. So that's going very well. And then we also had the thrusters, and we had the helium system leaks, as well as an oxidizer valve that's been essentially sticky. And so for all of those items, we've got various teams working what are the best operational and other testing opportunities that we have for those items. And we'll have a pre-departure telecon very specifically to address each and every one of those items. But right now, the teams are still working through what are the best ways to go about testing and preparing for that undock and reentry for those. So our outstanding operations team has put together a month-long plan that shows the opportunities for us to undock CFT from an orbital mechanics standpoint, as long as we have good weather. That happens every few days, and so where can we insert spacewalks has been kind of a challenge. As you know, we've delayed the CFT undock date to no earlier than the 18th. That gives us an opportunity to perform this EVA on time. To have it back-to-back, where we had an EVA followed by undock, was really not the most convenient. From an ISS standpoint, we did want Butch and Sunny to help us with a few things, and really the best course of action we all decided collectively was to push the CFT undock and leave the EVA on the same date. And then throughout the month, we've scattered the June 24th EVA, and then again in July 2nd is the third EVA. That's where we are able to spy good opportunities where we can still, if we had weather wave-offs, allow for CFT undock and have some amount of stability in our EVA planning. So, and that's the overall calendar. And now to get into what we're here to talk about, which is our 3 EVAs upcoming. The first one is Thursday, and we've got Tracy, Dyson, and Matt Dominick going out the door. This will be Tracy's 4th EVA. She'll be EV1 and wearing a red stripe. And this will be Matt's first EVA, and he's wearing a white suit with no stripes. The 2 major objectives for that particular EVA are the RF group, so radio frequency group electronics box retrieval. And I could go into detail, but you have heard this story twice before, since this is our 3rd time to try to retrieve this box. But we are trying to bring it inside into the airlock and then down on a future SpaceX mission in order to refurbish it from a spares perspective, and then we'll refly it. So that's our main objective, and you'll hear from Sandy next to me some of the details about how we're going to go out and get that box. Additionally, on that EVA, we've got the microorganisms task, and so this is a bit of research where we're going to swab some parts of station near vents and airlocks to see if any microorganisms can survive vacuum, and we'll bring that inside those swabs and then freeze the samples for scientists to look at on the ground to see what we have outside. So that's the first EVA this Thursday, and then on the 24th, we've got an EVA with 3 main objectives. The first one is to go and change out a camera, essentially just put an upgraded camera out there, and in doing so, we'll be using a crew member on the robotic arm, and we'll be doing a test while that is ongoing, such that the ground team will be commanding the robotic arm instead of the onboard crew in order to drive around the EV crew member. So this is new. Typically, we don't do that because it is a little bit slower and the rates are different. And so it's best if we have crew member to crew member comm, which we know will not be interrupted by loss of signal, that kind of thing. But we really wanted to test this out. Think about on Gateway, we'd like to have a lot more robotic operations that are remote, less dependence. I'd say with a crew member using a remote, an RHC. Hand controller. Anyway, we just like to understand what are our opportunities for the future for using the ground for control. Also, if we ever found ourselves in a situation where we only had we had 2 EV crew members and no one available to drive the arm on board, then how might we drive the arm around in a contingency type EVA? So this is just ideas that we had, and we thought this was a good opportunity. This particular EVA, we've been trying to look for a chance to do that. So we have that as our one of our objectives, and the second major objective is for the alpha magnetic spectrometer. In the future, we're going to be upgrading that, and so we're targeting early 2026 for that, for the main pieces to come up. So we want to check the work access for that and see what we can learn ahead of those spacewalks that will be needed for that particular upgrade. And then we're also moving another antenna that we have outside. This antenna is used for comm between the visiting vehicles and the space station, so in a rendezvous scenario. And we would like to improve essentially the signal strength and put it such that we have better line of sight between the actual visiting vehicle and the station. So we just really want to move it a couple of feet. So that's the second spacewalk. We're not announcing the crew members for that one nor the 3rd EVA yet, just in case we have suit issues or crew time availability changes, that sort of thing. So for those 2, we'll announce that after the first EVA is done. And so for the 3rd EVA, we have 2 major tasks. The first one is the installation of a modification kit, and this is our 7th one to install. We have installed 6 previously and also put IROSA's rollout solar arrays onto those mod kits. So we're going to put this one out for a future rollout solar array to be installed. And additionally, on this EVA, we're going to go out and change out a rate gyro assembly. So this particular box is used for understanding the attitude or orientation of the International Space Station. We've seen some degradation with it, and so we just like to get it changed out to get ourselves in the best possible posture. So that's, in a nutshell, the 3 EVAs. These guys next to me are going to talk about the details about how we're going to go about doing all of those. I'll just say to round out the summer, we're looking forward to an undocking of Butch and Sunny here, hopefully in the near future. And of course, they're seeing their smiling faces on the ground. We also have got a Northrop Grumman in the mid-July timeframe, a vehicle we're going to release called Northrop Grumman 20, and a Northrop Grumman vehicle that's launching in early August, Northrop Grumman 21, and that'll be bringing cargo and science. So before I hand over the microphone, I do want to say I'm super proud of the International Space Station team for everything they've accomplished this whole first part of the year. I'm looking forward to a really great summer. We have a lot left to do, and I'm looking forward to 3 fabulous EVAs. So with that, I'm going to hand it over to Sandy Fletcher, who's the EVA officer for the first spacewalk.
Thank you. Good afternoon, everybody. I'd like to introduce the members of my team. So in addition to the 2 spacewalkers on the ground, we'll have our flight director is Rebecca Wingfield. Our ground IV is Steve Bowen, which we're very fortunate to have our lead spacewalker from our first attempt of retrieving the RFG. My task leads are Miranda Nelson and Jenna Hansen. They were with us on the last attempt. And our systems team, Bailey Vega and Stephen Villano, they will actually be the systems teams for all 3 EVAs. Dina's talked big picture about what our major 2 tasks are. We expect Tracy and Matt to work the COM RFG task together. Tracy will then do the microorganism sampling test. That is a 1-person crew member task. So while she's doing that, Matt will work on a robotic arm joint prep. This is in case we do have to swap that out on a future EVA, and puts us in a better posture and makes it a little bit faster. So we call that a get ahead that helps us in a future EVA. The other task that he would do is we are changing out some adjustable tethers that have been in an external tool bag for an extended period of time, and we'd like to put new tethers in that place. So what's really nice about these particular EVAs, that even when the crew members are not working on the same task, they are in close proximity to each other and in the airlock. So we have one of the smallest footprints in terms of a spacewalk. In terms of going up and down the space station, we're pretty close together. We do have a video to show that talks you through each individual task, and you can see where the worksite locations are. This is the content for US EVA RFG Retrieve 2.5. EV1 in red stripes egresses first with a crew lock bag, followed by EV2 in white stripes. EV1 translates to the external stowage platform 2 and stows the bag, while EV2 translates over the platform to the forward face. Both crew work to release several quarter-turn fasteners on the multi-layer insulation tent over the radio frequency group. EV1 moves underneath the platform to remove the covering. Then EV1 visually inspects the radio frequency group and relocates the tool bag. Meanwhile, EV2 takes a portable foot restraint and installs it onto the robotic arm. EV2 ingresses the foot restraint and the arm moves to the next worksite. The crew will work together to remove rubber applied to the bolts on the aft wedge clamps. Then, using a ratchet wrench and a specially designed wrench, they will release the tension in the 5 clamps keeping the radio frequency group onto the stanchion. EV2 will return to the forward face of the stowage platform, then release 4 structural bolts using the pistol grip tool. Next, EV2 will slide the radio frequency group from the mounting plate. Then the arm will fly EV2 over to the airlock. Meanwhile, EV1 will translate to the airlock. After opening the thermal cover, EV1 will retrieve the microorganisms caddy and stow it externally on a handrail. EV2 will reorient the radio frequency group, and the tube crew will stow it inside the airlock. Afterwards, EV1 will close the thermal cover. Both crew will return to the external stowage platform to secure the multi-layer insulation covering over the stanchion. EV1 will go back to the airlock as EV2 retrieves the tool bag. EV1 puts the microorganism handle and caddy on their mini workstation. Then EV1 translates under the U.S. laboratory to the vacuum exhaust system's vent. The first sample will be in open space, and the second will be a swab of the vent surface. EV1 will then translate to the laboratory's carbon dioxide vent to sample that location. Next, EV1 will return to the airlock to swab samples at various locations around the airlock hatch. While EV1 performs the microorganism sampling, EV2 will go to the zenith or top side of the external stowage platform. EV2 will remove the multi-layer insulation covering a spare robotic arm joint. EV2 will release 3 of 6 fasteners using the pistol grip tool. Then EV2 will drive the joint's motor approximately 6 degrees. This prepares the joint if it's needed on a subsequent contingency EVA. After recovering the joint, EV2 takes the crew lock bag back to the airlock, where EV2 will replace some tethers in the bag. That completes the planned task for this EVA. So some of the lessons that we learned on the first EVA was there are 8 structural bolts as well as a jacking bolt. We released all of those. We did not have any issues with the structural bolts, but the jacking bolt is to try and maneuver the radio frequency group off of the stanchion, and it failed to move the box at all. So we went back. We had a rough idea. What we suspected was the issue was on the aft side of the box. There are these wedge clamps that are actually holding the box onto the stanchion itself. So we had to come up with a new way of releasing the tension. There are 5 of these. And if you remember the last briefing, we did talk about the RFG wrench, which was a specially designed tool. And that's to be used to hold the bolt head steady while we release the nut underneath it. That was our plan for the second EVA, but we had another task that had a higher priority. That was the trundle bearing assembly. That task took a little longer than we expected, so we went to the work site just to see what the state of these aft wedges were. And what we found is there's actually this glob of rubber on top of the nut to protect the crew from any of the threads that protrude there, because threading, especially metal on metal, is a potential sharp edge for the crew, and we're very concerned about anything that could damage the EMU suit and lead to a loss of pressurization. So people were very diligent. This is actually a sample based on the photographs that Jasmine took for us, and you can see somebody was very careful to make sure that nobody could accidentally access this bolt. But now we have to access this bolt, but I have to do that in a way where I do not risk the crew members' gloves. So our task lead, Miranda Nelson, came up with this great idea when the crew members told us that the previous tool suggestions we had were probably not going to work. So this is what's called an EVA wipe. So it's basically, I call it an oven mitt. One side is a terry cloth, which will not work for us. And the other side is kind of a shiny surface. And Tracy has already done this on orbit. She's built this. We've put 3 patches of Velcro hook on it, and that's going to be our gripping surface. So she's going to take her pressure, or actually this is handed off to Matt. Matt will do this task. In a pressurized glove, we do have spaces in between the hooks so that the crew member can essentially pinch where this rubber is. And I will freely admit we've already done it with this one, so it looks much simpler than what's going to happen on orbit. But by pinching the rubber and twisting it back and forth, we've shown in laboratory testing with the glove box that the rubber will come off pretty much as a cap. It will not be perfect. There will be some rubber that is still left on the threading, but by having the mitt, this is actually protecting the crew member's glove. It gives us another layer of protection while we remove the RTV. And all we need to do is have enough of the RTV remove the rubber from this nut so that while one crew member, and this will be Tracy, holding the RFG wrench, she'll hold that steady, and then Matt can use a ratchet wrench to release the threading. We are hoping we do not have to release all of this stack up of material. It should be enough to do 2 or 3 turns, and that should release enough of the tension so that we can pull the RFG off the stanchion. And with that, I will hand it over to Nicole.
Thank you. Good afternoon. As mentioned, my name is Nicole McElroy. I'm the lead flight director for the second of the 3 EVAs coming up this summer. I just want to reiterate how excited we are to get into this EVA series. The crews on board as well as on the ground are well prepared and very much looking forward to getting started with our EVAs. The crew on board has completed their fit checks, and the road to EVA has been going really well for us. And the teams on the ground have been doing a great job preparing all of the products and doing simulations to prepare to be ready to execute over the next few weeks. So to talk a little bit more about that second EVA, we're calling it the CP9 R&R EVA because our primary task is to go out and remove and replace a camera. The camera that's on the camera port 9 location, which is on the port side of ISS. We're going to remove and replace the HD camera that's in that location and replace it with one that has a wireless access point, which will extend our wireless capability for external things on ISS. As Dina mentioned, while we're doing this, this will be the first time that we are doing ground-controlled robotics with an EV crew member on the end of the arm. We do often do robotic operations from the ground, but this is the first time doing it in an EVA setting like this. As mentioned, it's usually done from the ISS crew member, but being able to do it from the ground gives us a lot more flexibility operationally. But while we're doing it in this specific EVA, we will have a crew member also on board following along and ready to take over if needed, although we don't expect that at any point. Another cool thing about this test objective is that it is an analog test for what's coming up for our Artemis Gateway missions, and that we are looking to use what we learn in testing and driving the arm in this way to further develop the operational concepts for when we're putting together the procedures and the arm for the Gateway module as well. While all of that's going on and that camera R&R is happening, our other crew member will be doing the C2V2 antenna move. As mentioned, this isn't a big move. We're moving it over 2 feet just to get a better line of sight between that antenna and our visiting vehicles on the way up, such that we can maintain comm and have good comm connection between the ISS and those visiting vehicles as they're on their way to station. And then the second half of our EVA is really dedicated to AMS preparation. As mentioned, there's some upgrade EVAs coming up in the future for upgrades to AMS to get it more data and higher accuracy. Like other things that seem to be on the outside of Space Station, it wasn't necessarily designed to be accessed EVA. So our EVA is really looking to test access to different electrical connectors and different parts of the device such that we can inform those upgrade plans and make sure that we have a good plan for those future EVAs as well. And that's all the details that I've got. I'll pass it over to Faruq, who's got a little bit more of the spacewalk details.
All right, thank you, Nicole. So the first and foremost, I would like to thank the teams that have been working tirelessly on this EVA. And then so that includes Jessica Whitner, who's going to be the ground IV, as well as Aki Hushide, who will be our Capcom. And we have our task members who have been helping me out, and are Emma Welch and Andrew Burr, as well as Derek Porter. And a host of other people who have been helping us. And then so I'd also like to thank my family for their great patience and undying support over these past few months, as I've been working very hard on this EVA. And then so with that, just as Nicole mentioned earlier, one of the first tasks that we're going to be doing is replacing this high definition camera. And then so a big part of that is, we're upgrading the capability on this camera. And ironically, to add the wireless access point, we need to connect the cable. So a big part of this task will be taking this extra cable that's going to be on the new camera and routing it in a very specific way that it doesn't impede the pan tilt capability that already exists for the camera while we install the new one. So the first thing we do when we get up to the camera is we remove and replace the camera, and then the next 2/3 will be just routing these cables to make sure that we don't mess things up. And then so while they're doing that, Nicole also mentioned the antenna boom that we are going to be moving over. So with that activity, we are, in order to move it over and have it be in a proper orientation, what we're going to do is we're going to use an extender that we normally use for a foot restraint. And then, but instead, because the interface on the extender and the foot restraints are the same, we're going to use the extender to attach the antenna boom to. So we will remove the antenna boom, we will put the extender in place, and then we will put the antenna boom back on the end of the extender for that activity. Another activity that EV2 will be doing is routing a jumper cable between two power channels on the P4 integrated equipment assembly. And what this will do is it'll allow, in a contingency scenario, it will add redundancy between the two power channels. And then so literally it's a jumper cable going from one point to another point. We just have to remove a couple of existing cables in the process. For the AMS task, or the alpha magnetics spectrometer task that we are going to be doing, we are just specifically looking at a patch panel. On this patch panel are the electrical connectors, and those electrical connectors we're looking for access, because the future EVAs and the future teams will be looking to which electrical connectors on that panel they have the greatest access to, which combination of those. And then so we're going to be looking for access to get in there. This is a very tight work site and was never intended for EVA operations. So when we're getting in close, we are going to have the other crew member will be a spotter crew member while the person is getting close to the work site. And then that is one of our stipulations to getting in close, so that we don't inadvertently damage the hardware. And with that, I have a video that I'd like to show. Welcome to US Spacewalk 91. EV1 starts by taking the bag with the high definition camera and translates port to the robotic arm setup position. They will temp stow their bag and translate to the camera port location to pre-stage some tethers and relocate an Ethernet cable to the base of the stanchion. EV1 will then retrieve a foot restraint and place it on the robotic arm. Then ingress the foot restraint and retrieve the bag with the new camera. EV2 starts the EVA by retrieving the worksite interface extender or width extender and bundling it to the cable bag. They then translate port to the P4 integrated equipment assembly to stow the cable bag. This bag is being pre-staged for the upcoming IROSA Prep 2 Alpha EVA. When complete, EV2 will take the width extender to the C2V2 antenna boom relocate worksite on the aft side of P3. EV2 will temp stow the antenna boom, then install the width extender, lastly relocating the antenna boom to the end of the width extender. Meanwhile, EV1 will ride the robotic arm to the high-def camera worksite. They will prep the old camera for release and demate 2 electrical connectors. After partially removing the camera, the window cover will be installed and the camera temp stowed. The new camera with the wireless access point cable will be retrieved and installed. Once the 2 electrical connectors are mated, EV1 will partially route cables and install a cable restraint clamp. While EV1 works on the camera, EV2 will retrieve the DC-DC converter unit jumper cable bag from the larger cable bag. EV2 will translate outboard to the P4-P5 interface to install the jumper cable. First, EV2 will remove an existing cable and stow it on the dummy panel. Then they will install the jumper cable across 2 power channels. This will add redundancy in case of a failure on either of the 2 power channels. And finally, completing the task by stowing the last existing cable on the dummy panel. EV1 continues to work on the camera by installing the cable restraint strap. EV2 translates to the camera to assist. First, they stow their bag and then translate to the base of the camera stanchion. Together, they complete the routing of the cable and mate the wireless access point cable to the Ethernet cable. With the camera install complete, EV2 retrieves their bag and then translates back to the airlock. EV1 rides the robotic arm back to the egress position. Once egress, they will retrieve the foot restraint and stow it. Back at the airlock, EV2 swaps bags for the Alpha Magnetic Spectrometer or AMS bag. They then translate starboard to the S3 AMS worksite to stow the bag. EV2 will work on relocating the starboard common communication for visiting vehicle or C2V2 cable in order to clear space for crew to ingress the truss near AMS. After stowing the old camera, EV1 translates to the AMS worksite. With EV2 as the spotter, EV1 carefully ingresses the truss to gain access to the AMS patch panel. The crew works together to fold back the beta cloth by cutting lacing cord. Then EV1 uses the connector DMA simulator tool on several cables to assess access. The 2 crew will carefully swap positions to allow EV1 to assess access with the tool. Prior to ingressing the worksite, EV1 will set up as the spotter. Once EV2 assessment is complete, the crew will take closeout photos and re-secure the beta cloth. EV1 will pick up the bag and both crew will make their way back to the airlock, concluding U.S. Spacewalk 91. As noticed during the video, We do have, during the camera remove and replace task, we do have a second crew member come over to assist with the primary crew member. And the reason we do that is, well, partially to speed up the task once the primary objectives of the ground M1 demonstration have been completed. It also allows us to get out to the next work site a little bit faster. So we do have that assist point in there. One of the objectives of the ground M1 testing is to transfer control from the ground to the ISS. So it is at that point where we will also transfer control of the arm so that the ISS robotic operator will control the arm for the remainder of that task. And that is all I had for the Spacewalk 91. So next, I will get into the U.S. Spacewalk 92. And then so for that EVA, I will be the lead EVA officer. And Fiona and Koviak will be the flight director, with Marcos Barrios being the ground IV and Sandy Moore being the Capcom. Along with her, my task leads for that EVA will be Lucas Widener and Lauren Maples. Again, for all three EVAs, we have Bailey Vega and Stephen Villano working with us on the systems or the suit side of the team. So for that EVA, there are two major objectives. The first objective is to replace the degraded rate gyro assembly. So as Dina mentioned earlier, the rate gyro assembly provides important data about the vehicle motion in all three axes. And then so because one is degraded, we need to go out and replace it. And then so what we are going to do is, in its location, the crew members have to be on either side of the truss, and then one crew member will go inside the truss, and then there'll be a primary crew member on the back side of the truss to gain access. They will pull back some thermal covers, and then they can gain access to the box, and then they will remove and replace the degraded box. In addition to that, once they are complete with that, there is the major task for this EVA will be installing the support structure for the new rollout solar array system. As mentioned earlier, we've done it 6 times before. There are 2 more times left to do it. One of those times is this EVA, and then in a future EVA, we will be installing the support structure for the last remaining power channel, and then there will be 2 separate EVAs to install the rollout solar arrays. And then so for that, the major task, we have a lot of these support structures coming out in a very large bag that is actually longer than the crew member himself. As they translate out to the work site, they will stow and then begin to put together the support structure and then install it directly onto the mass canister that is already holding an existing solar array. So it's a very sensitive piece of hardware, and we have to be very careful about how we install it such that we are not damaging the existing solar array while we install this support structure. And with that, I have another video to show. Welcome to U.S. Spacewalk 92. EV1 egresses and receives a large strut bag. EV2 egresses with a rate gyro assembly bag. EV1 then translates port on S0 and temp stows this strut bag. EV2 then translates port and over the truss to the aft side of S0. Once at the worksite, EV2 peels back a thermal shroud, stows the bag, and releases 2 bolts on the aft side of the box. Meanwhile, EV1 relocates a foot restraint and then ingresses the truss and releases 2 remaining bolts. The The crew released the degraded box and reinstalled the new rate gyro assembly. EV1 egresses the truss and retrieves the strut bag and translates to P4 to stove bag. EV1 then retrieves the foot restraint for EV2 and temp stows it near the worksite. EV2 cleans up the S0 worksite and temp stows the degraded rate gyro assembly. EV2 then picks up a foot restraint extender and installs it in the P4 worksite, and then installs the foot restraint. EV1 builds the upper triangle of the structure that will hold the new solar arrays. Once EV2 ingresses the foot restraint, EV1 passes up the upper triangle with cables to be installed. The crew reconfigure the foot restraint for the next position. EV1 passes up the mid strut and the crew install the lower right strut. Next, they work together to install the right mid strut. EV1 passes up the two left struts and then repositions EV2 on the left side. They install the left lower strut and then they install the left mid strut. EV2 egresses the foot restraint and stows tools and empty strut bag in the cable bag. Meanwhile, EV1 drives final torque on the collar bolts on the left and right mid struts. Both crew work together to install thermal covers and route cables on both sides of the mod cable. EV2 returns to the airlock with the cable bag. EV1 first stows the foot restraint and extender and then retrieves the degraded RGA bag and takes it to the airlock. And that concludes US Spacewalk 92. All right, so as you see in the video, there are a couple of things of note in terms of helping ourselves out for future EVAs. So for the CP9 EVA, one of the things that we're doing is we're taking out a cable bag to pre-stage it for the EVA 92. And that is because the EVA is really full and the airlock is also very full. And then so by taking the bag out early, we can pre-stage it to allow for the full EVA to maximize its time with the work that it's actually doing outside. In a similar fashion, the cables that were routed at the end of the video, those are for the actual EVA where they will be installing the new solar arrays because that EVA is also very full. So by pre-routing those cables, it saves them time on that future EVA. And those are all the things I had for US Spacewalk 92.
All right, thank you to our briefers. At this point, we will go ahead and open it up for questions here in the room, as well as on the phone bridge and on social media. As a reminder, for those on the phone bridge, you can press *1 to ask a question. If your question has been answered, you can press *2 to remove yourself from the queue, and those on social media can use the hashtag AskNASA. We'll start here in the room with Gina.
Sorry, ABC News for Dina. When you collect the samples and then move them inside, do they have to be refrigerated, and when would they return to Earth to be analyzed?
We actually put them in a freezer called Iceberg. I think it's at minus 95 C. I just heard this morning, so but maybe you shouldn't quote me. But it's very cold. So they're frozen, and we'll bring them home. I'm not actually sure. Does anyone know on my panel about when? But our opportunities are either crew flights or SpaceX missions to bring home those samples. So, when we bring it inside, we actually disassemble it a little bit to get it into the freezer get the samples in. So we have a handrail and a bayonet fitting on the box in order to make the samples slide into the freezer a little bit better.
Are you curious to see what they come up with?
I am. So I think there's bacteria and fungi possible. I'm not sure what we're going to see, but again, there's vents and near the airlocks, so something that has come from inside out. But just to see what we'll learn about what survives on ISS.
All right, next we'll go to Mark in the room.
Thank you, Mark Carreau with Aviation Week and Space Technology. I'm wondering if you can recall for us the EVA where they removed the radio frequency group and temporarily stowed it. I know it wasn't too long ago, but it's just slipped my memory. And I think, did they have to do it twice, stow it twice or just once?
If you talk about the current radio frequency group, I think if you're talking about the current one, we had one in November and one in April last year. Neither time did it come off. So it's been sitting there. I'm not sure when it was moved because it's a failed unit. Do you know, Sandy or Faruq?
Yeah, I think it was back in December of 2023 that we had to do a EVA. This is a degraded unit. It's not completely failed, which is part of the reason we want to bring it back. And we moved it from the P1, Port 1 area, and we put it onto what we call a FRAM, which is the stanchion then bolts down onto this FRAM, which we can maneuver around station, and robotically it was moved to ESP2 to help us actually expedite trying to get just the communication box. When it's attached to the stanchion, it will not fit into the U.S. airlock. So really the biggest challenge is trying to decouple something that was not meant to be decoupled EVA.
All right, we'll go on the phone bridge. We have Stephen Gorman with Reuters.
Yeah, hi, thanks for taking the call. I have a question about the microorganism sampling. Is this going to be the first time that that anybody swabbed, the exterior surface of the ISS for microbes, possible microbes, or has this ever been done on any U.S. spacecraft before? Is this kind of a first, or has this been done before? I think you mentioned in your literature that Roscosmos had done similar sampling on their side of the space station before, but maybe this is the first for the U.S.?
So I will say we have exposure samples. I'm not sure about swabbing particularly, where the crew goes around. I'm not aware of us ever doing it before on ISS, at least on the USOS side. We might be able to look up some information for you, though, to see if anything like this has been done. Certainly, we do have exposure experiments, and I know that there is a group of scientists that's very interested in this. For example, for going to Mars and understanding what we might carry with us to the Martian surface, accidentally discovering something on the Martian surface that actually came from us, that kind of thing. So, there is a large group of scientists that's interested in this. So. We'll have to get you any, historical information on this side. We'll look that up for you.
All right. Next up, we have Bill Harwood with CBS.
Thank you very much. Regarding the AMS access in the upcoming EVA, how tight is tight? In other words, the astronaut's down in the truss halfway, I guess. But I mean, is he sticking his hands, or he or she sticking their hands in there to judge whether tools would fit? I mean, it kind of just describe the whole access issue and what you're trying to learn. Thanks.
Yes, so I can do that. So tight is relatively tight. And then so in general, like mentioned before, the crew member is sticking their feet halfway into the truss. And then so the patch panel is actually on a lower beam of the AMS hardware itself. And then so largely it's the patch panel that they'll be most concerned with, and it's getting access to that work site without touching any of the sensitive areas on the hardware hardware itself, which can be challenging. And that is why we have a spotter, the crew member on the outside, really kind of observing some of the no-touch areas to help the crew member get into a location where they can access that patch panel. And then so once they access the patch panel, they'll be taking a small tool that would simulate a connector demate tool, and then they will put it directly over the connectors to assess the access. And then so this will all be within their nominal work envelope and volume.
All right, we'll take a quick question on social media. JV Mills on Instagram asks, how long do spacewalks usually last?
Well, we have 4 experts up here. I'll chime in with about 6 hours and 30 minutes is what we plan to. And then we have a lot of discussions ahead of time. Are we willing to extend to say 6:45 or 7 hours and for certain types of objectives? But that's our nominal planning time. I think that's probably the answer for this question.
All right, next up we have Sophie Sanchez with Cosmic Chicago.
Hi, thank you for taking my call. Could I just get what is the time delay between ground control and station for that second EVA? And then also, did ground control and the astronauts train for this mission? And can you, or for the analog test, and can you just give us an idea of like what that training would have looked like? Thank you.
Yeah, so the teams have definitely trained for this operation. We've actually introduced a new role into the Mission Control Center that is dedicated to doing the ground control and also talking with the astronauts while they're doing their spacewalk. And so we've practiced that in small team environments as well as a full simulation in which we practice where things go well and as well as where things maybe go a little off nominally, so the team is prepared to handle anything that may go off script during the day. Similarly, the astronauts are practicing this same thing as they're doing their preparations for the EVA and have talked with the ground operators and done some robotics practice on board so they know what to expect and what to look like. Really, the test is trying to understand and look for opportunities as we're looking forward to Gateway is just different ways to drive the arm. When the crew on board right now drives the arm, they use a hand controller. And so when we're driving it from the ground, we're using a series of different commands. And so we're understanding the difference in that. And as we talked about, as a result, we'll be driving just a little bit slower this time around and a little bit more conservatively, but we'll be able to make sure that the crew can get to anywhere that they need to go.
All right, and one other one on social media, 5-year-old Paul on Instagram wants to know if the astronauts get hungry, do they have snacks?
Unfortunately, no. They do take some water out with them when they go out. A lot of the astronauts that we talk to make sure to eat a fairly hearty breakfast, I think, before a spacewalk, and then they get a little hungry when they come back inside.
All right, back to the phone bridge. Steve Gorman with Reuters has a follow-up.
Yeah, I have another question about the CST, the Starliner. Do the CST's propulsion problems, issues, need to all be resolved, sort of understood and fixed before that crew will be allowed to undock and return to Earth?
Well, so just to give you some examples, by resolve, certainly we'll all need to agree on what the plan is and that we all believe that we're ready to come home with the crew on board. So the answer to that is yes. But for example, we have got one thruster that we're not sure that is going to return. We might try to hot fire that away from station, but we would be using the other thruster sets, for example, and we'll go through the operations for that, make sure that's acceptable. And one thruster, of course, would be acceptable to come home without. For a helium leak, there are a number of helium leaks on board, and we can't really stop those necessarily, but we can manage the consumables usage by closing and opening valves, shortening the time frame for the crew to come home, just generally making sure that we have enough. And currently we have a lot of consumables if the leaks stay at their current rate. So we have a lot of helium on board. So that's the way we're talking about resolving and managing the types of observations that we've seen thus far on the mission. But we'll just walk through each and every one of those methodically this week and make sure that everybody is in agreement with our forward plan.
And as a reminder, we are also planning for a pre-departure briefing with management, and we'll share details of that once it's available. Back in the room with Mark Carreau.
Yes, thank you, Mark Carreau with Aviation Week and Space Technology again. When you're doing the ground control robot arm activities, are there some limits on this exercise that restrain what they can do that they wouldn't be restrained from doing if they were controlling from the space station? And, you know, I'm just looking for if there's, I know you're working on a plan, and so this could all change, but I just wonder for this exercise if there's some restraints that you'll be observing.
The biggest constraints that we're putting in place is really the speed. So there's no physical places the arm can or cannot go from the ground. We do have a planned flight that we expect the arm to fly to take the EV crew member out to that location to remove and replace the camera and then fly back. And we've simulated that as well as put it through all of the different robotics VR lab in order to make sure that we expect we have good clearances, et cetera. So everything that we expect to do is known. And then there's a bit of flexibility when we get to each of those work sites to be able to move the crew members a little bit left, a little bit right in order to be able to reach and touch the things that they need to. And those constraints are the same for the ground team as they would be for the onboard team of the box in which we can move someone around and understand the limits there. So the biggest thing that we're really doing is making sure that when we're doing those maneuvers, we underestimate how far the crew member needs to go at first. So if they need to move in closer into station, we'll move them just a little bit at a time and make sure that we're not overshooting any of the maneuvers that we're doing.
All right, and one last question on the phone bridge from Bill Harwood with CBS.
Yeah, it's just a follow-up for Faruq on the AMS work. When you talked about being on guard against damaging any hardware coming into contact with stuff when you're dealing with that tight workspace, is that primarily cabling, wiring, or is there some structure on AMS that's particularly fragile? I'm just trying to understand what it is you're guarding against an inadvertent tap or hit by the crew member. Thanks.
Yeah, and then so most of that is the cabling in there. So in particular, there's one cable called the ACC cable that is a light sealed cable, and that is, you know, critical to the data that is received from the hardware itself. And then so obviously if you bump the light sealed cable and allow extraneous light to go into that box, then you know you destroy the results. And then so that's the major one that we are very sensitive about not coming into contact. But there are also a number of other cables on the hardware itself feeding information and sensory data that, you know, we're working in a work site where those weren't intended that crew members would necessarily be. And then so we're just wanting in general to be sensitive around a lot of cables that, you know, weren't intended to have crew members around them.
All right, that's all the time we have for questions today. We hope you'll tune in to each of the spacewalks. NASA TV coverage of the first spacewalks this Thursday, June 13th, will begin at 6:30 a.m. Eastern, 5:30 a.m. Central. Thank you again for joining us.